Okay, this is my time series data. You can see I have data for 12 time periods. So I'm interested in doing a forecast using this data. We'll do a forecast based on all methods which we have seen in the earlier videos. So before we get into the actual forecasting, let's do some exploratory analysis. What I'll do is I'll first plot a line chart to see if there are any trends or seasonality in the data. So insert line chart. Okay, so this is my line chart for 12 time periods. These are my values. So on looking at the chart, I can see clearly that there is a trend. Data starts here and there is a constant trend where it is continuously increasing. Moreover, I can see a seasonality as well. There are alternating peaks and depressions in the chart. So I conclude there is a trend as well as seasonality in this data. So we'll see how to forecast using each method and how each method performs. Okay, we'll start with the naive forecast first. What I'll do is I'll add a column saying forecast. I'll add a column for error. So we'll measure the forecast error as well. Okay, if you remember naive forecast, what I do is for the current time period, my forecast value will be the actual of the previous time period. That is naive forecast. So for time period 1, I won't have any value. For time period 2, it will be 120. So using a formula, I'll just write it as equal to B2. I'll just copy paste this formula. And for the 13th time period, my forecast value will be 950. So one thing should be obvious from this. You shall be able to forecast for one time period ahead only. I cannot forecast for the 14th time period here. Only till 13 I can do. So using the naive forecast method, we will be able to forecast only one time period ahead. Okay, now let's measure the errors. So error, as I said, is the difference between the actual and predicted value. This minus this. So we'll measure the errors wherever we have both the actual value and the forecast value. So for now, I am not considering the 13th time period. So in real life scenarios, how you actually do is when you have data for a huge time period, you have data for say 100 time periods, you take the data of first 80 time periods to build your model and then validate your data against the rest 20 time periods. For the rest 20 time periods, you compare the actual and predicted values and determine how your model is performing. So here I am just showing you a simple model with 12 time periods and I am validating the data against the same 12 periods. So these are my error measures. Okay, since I am interested in comparing the errors across all models, what I will do is I will calculate the MAPE, mean absolute percentage error. So for that, I will have to calculate the error percentage, which will be, so it will be the absolute value of this, absolute value of your error divided by the actual value. I'll denote it in percentage. Copy paste the same formula to get the percentage error of each observation. So this is what I get. So my MAPE, mean absolute percentage error, will be the average of all these. So this is your mean absolute percentage error, comes out to be 101%. So your mean absolute percentage error comes out to be 101, which looks quite on the higher side. We'll see how the other models are performing before we draw our conclusions.